So now we have finished discussing the specifications of these three broadcast services. And we are now going to talk about their implementations, about the actual algorithms that can be used to implement these services. So before we proceed with discussing the broadcast implementation, let's briefly review the model assumptions that we're going to use for the rest of this lecture. So we're going to assume the fail-silent model. And to remind you, in the fail-silent model, the processes don't have access to any kind of failure detector, neither P nor eventual P, which means that we're basically operating in an asynchronous system where we don't have any time bounds on link latency or the process speed. So in addition, we also assume that processes can crash, so the processes are crash stop, and we also have access to the point-to-point links. So we can send the message over a perfect point-to-point link, and we can receive messages of the perfect point-to-point links. Okay, so our first algorithm is called basic broadcast, and this is algorithm 3.1 in the textbook, and this algorithm implements best effort broadcast, or BEB. So in the nutshell, this algorithm is just a reformulation of what we called iterated unicast at the beginning of the lecture in our event-driven component model, right, using the pseudocode conventions that we discussed. So in slightly more detail, so what happens here, so whenever we get a request to broadcast a message from the upper layer or from the application, what will happen, we just delegate it directly to the perfect point-to-point links that we have available for all the processes in the system. And so the set capital Pi here represents the set of all processes in the system that we have assumed is known to everyone. And the process, it would simply iterate over all processes in this set, and it will invoke the send request for every such process as a destination to send message M to that process. Okay, so this is basically just the iterated unicast written slightly more carefully in this more mathematical notation, if you want. So to deliver event to an application or to an upper layer, we basically, so the deliver occurs every time we get a deliver from a perfect point-to-point link. Okay, so whenever that happens, whenever we get a deliver from the perfect point-to-point link in this line here, we immediately take the message that we received and we trigger the best effort broadcast deliver to the application. Okay. So this is a very simple implementation, and I hope it is clear. Okay, so let's just briefly see why this implementation is correct. So to show correctness, we need to prove these three properties: validity, no duplication, and no creation. So all three properties basically just immediately follow from the respective properties of the perfect links. So in particular for validity, if sender does not crash, then every other correct process will deliver a message, because that's just basically implied by the corresponding validity property for or reliability property PL1 of perfect point-to-point links. So the same goes about node application and node creation properties. So they just immediately follow from the respective properties of the perfect links, which are PL2 and PL3 in these two cases. Okay, so basic broadcast is a simple algorithm, and it is actually straightforward to implement best effort broadcast given that we have access to perfect point-to-point links. Okay, so now let's consider implementations of the more advanced abstractions.